Welcome back to Neal on Fire, where we talk with people building the future of wildfire detection, mitigation, and response. Wildfires are becoming more intense, more destructive, and more unpredictable. Most of today's systems focus on detecting fires once they start. But what if we could identify wildfire risk well before ignition using data most people aren't even looking at? Today's guest is Dr. Supratik Mukhopadhyay, whose research connects artificial intelligence, satellite data, and a wide variety of environmental data sets to rethink how wildfire risk is identified and forecasted. His DeepFire work at Louisiana State University is designed to detect both smoldering fires and active flame ignitions, not just fully developed wildfires. Supratik, welcome to Neal on Fire.
Thank you. Thank you for inviting me to this podcast.
So, what originally drew you to apply AI and geophysics to wildfire research?
So we were looking at, I've been doing research on artificial intelligence for more than 20 years at that time. And this was around 2018, say. And we have been doing research in different areas because we were already working with NASA on, several things creating land cover, high resolution land cover maps over the continental US at 1 meter resolution and so on, right? So the person with whom we were working at NASA, right, at that time, Rama. So one day we went to, I was at the Ames Research Center, right, and I went to his office and he said, "Oh, I'm going to show you something new." And then he was showing me this, using LEO satellites to detect wildfires. And that caught my attention, but I didn't think about it much. But then I saw slowly after coming back from Ames, right, that wildfires are becoming more and more pervasive. And it's really a danger to civilization at this point because, wildfires in Alberta are creating, hazardous air quality in New York City. That's the extent which wildfires can go. And of course, we needed to save other parts of the world, like the Amazon rainforest, which got affected. Hawaii came, right? Hawaii incident came, and so on. So at that point, we started looking at, okay, wildfires are there, right? How can we make or eliminate destructive wildfires, right? So that was the question that we were asking, right? And we figured out that current state of the art. And this is what Rama told me from NASA, right? At that time, when I was talking, what was like 70% accurate in detecting. That's a pretty bad state of the art. 70% is, 50% is random. I can toss a coin. 70% is slightly improved. So we started thinking that what can we do? So first thing is, of course, wildfires were getting detected quite late after they have started, when they were already doing damage. Something needed to be done. Second, we also observed that the amount of resources for fighting wildfire, available for fighting wildfire, is quite limited. So they needed to be deployed very wisely. So how can we develop a decision support system that can, not only detect wildfires early, but also predictively allow deployment of these scarce resources to fight wildfire? So that's where we started. We basically started building our engine, and we already had this experience with the DeepSat, which is we already built, So the high resolution land cover maps, we pioneered it essentially at that time in collaboration with Rama and his team at NASA.
In simple terms, what is DeepFire and what is the gap it's addressing that current wildfire detection systems are not?
Okay, so DeepFire is a combination of multiple agents, I would say, in today's terminology, multiple agents. So one of these agents is basically, so to fight a wildfire, you need to know, or detect a wildfire, you need to know where to look, right? That's your first thing. So the first agent's job is to predict when the wildfire is going to happen. And this prediction is on at different time scales. Like I can say that the next 7 days, these are the wildfires, right? In the next 14 days, these are the wildfires. Next 28 days, these are the wildfires. Next 45 days, these are the wildfires that are going to happen. And this we can do at more than 90% accuracy. So which means that if I say that, okay, and in this stretch of land here, there'll be wildfire within 2 weeks, with 90% chance it's going to happen. So that gives us, first thing that gives us is where to look. So that drives the second agent, which is basically a detection system. The detection system's job is basically to look for those areas that the prediction system already predicted. Okay. that this is when the wildfire will happen, and this is the probability in which the wildfire will happen at that time. So it knows when to look for which places. So then it's waiting, of course. Of course, this gives you another thing. Of course, even before the wildfire can happen, you can take actions like, clearing brush and so on. Whatever actions you can take. Okay. And also, you can get your equipment and the scarce resources that you have ready at those points. Because, with 90% chance, wildfire is going to happen there. Okay. So that's the second decision. So now, if the wildfire starts, even after all your efforts, we already know, we are already looking at it. So we detect it very, very early, just when it starts. Okay. Then once that wildfire starts, right, there are two things. So the detection engine detects and sends it to a third agent, which is basically a spread engine. The spread engine basically starts tracking the spread of the wildfire. Okay. And then the detection engine and the spread engine both communicate back to the prediction engine saying that now the wildfire started here. So now, and is going in this direction, right? Based on the wind and so on, right? So then you have to modify the predictions around the surrounding regions because, the wildfire is moving in this direction. So whatever you predicted now, it's basically, you increase the predictions in those regions. The probability of those regions. So it keeps on tracking the wildfire, the spread engine, and as the responders move in and start dousing the fire, it keeps on tracking. So, and it's basically simultaneously communicating with the other two agents, saying that, okay, look, now the spread is in this direction. So the detection engine, you better look at this direction, this way, because the fire is coming. So this interaction that you see, that's the gap that you are seeing. I mean, you don't see in normal systems.
Understood. So, from what I'm aware of, there are 30 different data sets in the system, including climate, vegetation, weather. So, which of those 30 data sets do you think are often overlooked as indicators for wildfire detection? And which ones do you think, if you were to kind of net it out, are the most valuable for that?
Yeah, we did. I mean, brush is certainly a very important factor, right? And often what happens is that, because of the canopy cover, you're not able to get access to the brush. The amount of brush accumulated in the clear way. So what we do is a proxy. So if the brush has accumulated, right, you should see the mark on the trees. Where did the brush come from? So that's a very important indicator. So as I said, that those land cover maps that we built with NASA, they are very important. So if we keep on building those, the tree canopy cover maps and so on, those are very important indicators because where did the brush come from? So from there, you get immediately a lot of information, when the brush is accumulating, because you look at the state, because you cannot go down, right? Because you cannot penetrate down because of the canopy. So it's a full canopy cover, right? The satellite cannot look down, right? So if you look at the state of a tree and how the state of the trees are changing, right, that's a very important indicator of what type of brush is getting accumulated and how much is getting accumulated and what times it's getting accumulated. So everything. So that is a game changer, actually, if you can look at that very carefully. That gives you the plan.
So, with that in mind, how far in advance can you predict wildfires before ignition or extreme wildfire behavior?
We have four or five different time scales. 7 days, we can say 7 days before. We can say 15 days before, then 28 days before, and then 45 days before. So almost 1.5 months before, we can say, with quite
Okay. So, with that early prediction, how do you validate predictions that haven't yet occurred? How do you ensure that you don't have false positives and that?
That's because of historical data, right? We basically benchmark our system, calibrate our system based on historical data. So we basically do height casts, where we know the fire has happened without using that part as our training data. And then we see those predictions. Is it predicting the fires that we know have happened?
So you had mentioned 90% accuracy. Does that say 10% are false positives? I mean, how do you handle false positives in the system?
False positives means there are several ways in which we do false positives. So one is that, sometimes not only false positives, you sometimes do not detect, a fire, or sometimes you make a false prediction that a fire never happens, you're predicting a fire. So these are two cases. So we also have a confirmation system Confirmation system. Confirmation system, we essentially have a truck-mounted camera, which is a camera which is on a tower, which is on the bed of a truck. So they go there, they have long-range cameras, which can see actually Germanium code cameras, which can see 25 kilometers at distance, and then they take a picture of it and come back. And based on that, we have another analysis from a different angle. It's not based on satellite. It's basically straight camera angle, and then we basically want to check if using a second algorithm, right, whether a fire is going to happen there from that angle as well. That's a very close angle.
Right. So we're talking about using PTZ cameras and integrating that data into DeepFire. What
Right.
about using other sensor data, smoke sensors, ground sensors, whatever it may be? Do you currently integrate that? Is that part of the plan?
That's part of the plan. We currently don't have access to that, but we are actually getting some customers who will give access to that at this point. Right? At this point, it's satellite. Then you have the PTZ camera for confirmation. PTZ camera, because PTZ camera is expensive, right? You only use for special cases, like when you think that the probability that it's giving, right, is borderline, right? So it can go either way, right? So then you use a confirmation system to do that. And of course, we use the PTZ camera when there is a fire, but we are detecting a fire. Is that a real fire? Once we detect a fire, have we detected a real fire? We use the confirmation system. And also we are also one of the, we have some important results on out of distribution detection, right, which we use here actually, based on an image, right? If the algorithm has never seen a certain type of fire before, right? Let's say certain pattern of fire before, right? It will tell you that, look, I don't think I know this well, right? So you basically try a manual means instead of doing
that makes sense. But with that in mind, what does success look like for DeepFire? Is it primarily focused on uh, predicting probability, timing, location, severity, or all of it?
all of it. All of it. So because you have these four agents, right? Four agents that are simultaneous. Prediction tells you what to look. Then you look. Then you pass it on to spread. Spread says, okay, why it's spreading, right? And then you have the confirmation as well. So all four of them are basically simultaneously looking at it. So far, we haven't integrated it with the response system, but at least we are, as far as tracking, detection, prediction is concerned, we have a full suite.
You mentioned response. So if a fire agency or utility were using DeepFire today, how would that fit into their operational workflow?
Okay, so first thing is that the prediction that we make that already tells you where to where your scarce resources, how to deploy your scarce resources, where to look and where to deploy your scarce resources. And that also tells you that, okay, maybe if we go there and clear up the brush, the chances might reduce. It still might happen due to one lightning strike, because you may not be able to clear up all the brush. So that's your first response. Then once the fire starts, right, because our system now knows where to look for, right, and it will give you the immediate indications of the fire, how the fire is spreading, which area, right, currently the fire is going, right, intensity and so on. Right. So that gives them an idea of what kind of response is needed, right? And as they're responding, right, the confirmation system is also tracking how the response is there, right? So it's basically informing the prediction system and the direction system where to look. Why is the fire next going? Depending on the wind speed.
Sure. No, that makes sense. So my question is, can DeepFire be used anywhere in the US, in North America, the world? Give me a sense of the area of coverage currently.
So right now we cover, for example, the western part of US, the western part of Canada, Indonesia, and Australia. Okay. So we are having some customers in Greece. That's our next target. And in South America, that would be our next target.
And are your customers primarily at a proof of concept level? Are they primarily academic institutions or government institutions? What are the plans in terms of getting this to market for a broader audience?
So the DeepFire technology has already been licensed by a company called Firemark AI, based in Calgary, Canada. Right. So they are basically getting it. So they are already received funding from Alberta Innovates for building the system. And that's how the system has been supported, collecting the data and all those things. So now we are basically, trying to get it across into several states in Canada and, of course, in Australia as well.
And do you see DeepFire as a replacement for existing tools or more of an addition into the wildfire ecosystem?
I don't see it as a replacement for existing tools. It's basically an augmentation, AI augmenting humans. Humans are never out of the loop. We are never going to replace the humans because, in this case, because it's a critical scenario. AI can always make mistakes. As I said, 90% accuracy, it's not 100%. Right? So 10% of the time, you're making a mistake. So, and the detection system is around 80% accurate, right? 80 to 85% accurate. So 15% of the time, you may not detect it, or you may detect something that's not a fire. So humans will be the ultimate judge. Of course, we are using all kinds of sophisticated techniques to make sure that that these false positives, as you say, are as few as possible, but still there are limitations.
So, when we talk about this being deployed to fire agencies, do you see that it being directly connected into their systems, or do you see more of a man in the middle approach where somebody looks at the system and then they are validating whether, in fact, it's a fire event before it's passed on to a fire agency?
I see the latter. It's a system augmentation. We don't want to integrate it directly into the system. We may not integrate it, but it's basically gives them an augmentation. It is basically a tool in their hands.
Understood. So your system is, you talked about it being used in Canada and the Western US. Does it apply well to any type of ecosystem like a forest, grassland, or other climate? Do you have to make adjustments for that, or is it automatically going to make the adjustments necessary?
So we use a lot of transfer learning. Of course, it transfers somewhat to other ecosystems, but essentially fine tuning is needed. So, for example, if you see New South Wales in Australia, right? So Eastern New South Wales and Western New South Wales have a completely different geography. So what works in Eastern New South Wales usually is basically, for something it's completely different from what works in Eastern New South Wales may not work in Western New South Wales, and we have seen that actually. So what we do is a lot of fine tuning, different types of land covers, fine tuning for different types of land covers, ocean currents. Ocean current is a important factor for prediction, for example.
So, what do you think governments and others misunderstand about AI driven wildfire detection systems like this?
I don't think they misunderstand. I think today we all know that AI is a force multiplier in different areas, and the government has already started, as you know, the Genesis program that uh, AI for discovery, AI for discovery in the sciences. So, I think as we in the near future, we'll see more and more use of AI in disaster mitigation scenarios like wildfire and other scenarios like, even flood prediction, flood prediction, flood response. So those kind of scenarios. So I don't see AI going away anywhere.
So, what do you see as the next enhancements for DeepFire? What other functionality do you plan to add in?
So I think there are a few functionalities that we want to plug in, and of course they're expensive. One of them is synthetic aperture radar because we want to penetrate through clouds. So that's something we are lacking today. We cannot penetrate through clouds. And for example, in a recent run, I think we were not able to detect a few things in New South Wales, few fires, because we couldn't penetrate through the clouds. So that's a major thing. Another important thing is for when we use satellite image, right? By the time we get the satellite image, there's a delay, and analyze the satellite image, right? Imagery, there's a delay. So now the next generation of wildfire technology will basically be run in space. So the AI will directly be run on space. So most of the processing will be done in space, and the outputs will be delivered instead of sending the data here. The AI should sit where the data is collected, which is in space. So that should be a major change in reducing the latency, in mitigating the reducing the latency, in mitigating the delays in wildfire response.
Could integrating ground based sensors, things that are operating in real time, be a way to address that latency issue as well?
Yes, but these are expensive, right? You don't have these everywhere, and they're expensive. I mean, these are vast areas. Think about, for example, the entire state of Alberta in Canada, right? It's a huge area. So how can you? So of course it will be done at some point, but in deploying sensors, right, everywhere in the state of Alberta, for example, it will be hugely expensive. But we'll see what can be done. But again, there'll be problems with sensor interpolation because you may not have sensors everywhere. So how do you interpolate? If you have seen something on this sensor and on this sensor, how do you interpolate somewhere in the middle? So those problems will be there.
So, with your current installations, are there any milestones that you want to share? Any fires that were detected within a certain period of time? What does that data look like so far from those early trials?
From the early trials, I think prediction, as I said, is 90% accurate, more than 90% accurate. Detection is 80 to 85%. There is a fire because we use the confirmation system, right? Confirmation system goes and confirms if there is a fire, if there is a real fire or not. So, and that's how we judge the accuracy of the system. Has it detected? Has it failed? If you detect, then is it a false positive? Okay, the confirmation system says it's this seems to be a false positive. Or if it says no, then also the confirmation system points to that direction and says, look, there was a fire that you missed.
So, you've talked a little bit about the challenge with latency with the satellite data that you're ingesting. Do you have a sense, have you kind of quantified what that means, that latency? Like, how long does that delay your potential detection?
It can delay up to 1.5 hours, which is a long time. The fire has already done whatever it wanted to do or whatever it was supposed to do by that time.
So, where do you see DeepFire in another year? What are the enhancements that you would expect to add in, or even 3 or 4 or 5 years out? How do you think tomorrow's product is going to be different than what you have today?
I think a few things, like one is space-based deployment, space. So the AI should run in space. So that's a major thing. Second is synthetic aperture radar. We need to penetrate through clouds and so on. Third is, of course, ground-based sensor. And fourth is more powerful AI. So which means more computing power, more powerful AI, which is coming. So these are the main four things that we want to integrate within DeepFire, apart from better user interface and so on.
So, we've covered quite a bit about DeepFire and your research at LSU. Is there anything that we haven't covered that you'd like to touch on?
I mean, there's a lot of geospatial work that we are doing at LSU. So some of that work is very complementary. For example, we are also trying to predict in the Arctic the permafrost degradation, and that also has huge impact for wildfire as well, as you can understand. Wherever the permafrost is degrading, right, there is a high chance of wildfire there. Okay, near that spot. But it has other impacts. So for instance, there are pathogens that lie under this permafrost, right? Once that permafrost degrades, these pathogens get released to the atmosphere, and we may not have any immunity to these pathogens because they have been sitting there for millions of years. There's another danger to human health, which is like a radioactive radon sitting there underneath that permafrost, right? Once the permafrost degrades, then that radioactive radon gets released to the atmosphere, and that's a real hazard for human beings. So those are the things that we are also studying, apart from things like, recently, like, dead zones in oceans and so on the Gulf, especially in the Gulf Coast.
Supratik, this has been a fascinating conversation. What stands out is that wildfire risk doesn't just start with smoke or flames. It can start with signals and patterns that DeepFire can help us understand in a new way. And that the work that you're doing with DeepFire and coupling 30 data sets with AI is really interesting. It's been great learning about everything that you're doing with DeepFire. Thank you so much for joining us on this episode. And we really appreciate it. And certainly anyone who wants to learn more can go on the LSU website and search DeepFire to learn more about the program.
Thank you so much. Thank you for inviting me to this podcast.
Thanks for tuning into this episode. I'll see you next time on Neal on Fire.
Thank you so much. See you.